Okay, so here's the curve. It's a cubic curve because it's got power 3. Now with a quadratic, it's either an N-shaped or a U-shaped curve. This is a quadratic curve. With a linear curve, it's a straight line, isn't it? So it can either look like that, like that, like that. So on, that's a straight line, that's a quadratic. Now a cubic curve, which is of this form, generally can look like this, well, like this, or like this. So it can go up, down and up, or down, up and down, depending on whether this is positive or negative. The same goes here. This is an N-shaped curve if this is negative. If it's positive, then it's a U-shaped curve. If this is positive, the line goes up. If it's negative, the line goes down. So these are the characteristics of linear, quadratic and cubic curves. Here you get morphs. You can see how this might morph into something that looks like this. Yeah? Because these 2 points can just join up and overlap each other and you get a curve that looks like this. Similarly, these 2 max and mins could just merge into one. You get a curve that looks like that. But characteristically speaking, it's in principle it's just a down, up but not an up, and then a down again because it flattens out completely. So that's the sort of bump that we need then to draw these things. So I just wanted to mention that at the beginning of this example. Now we'll have a look at the curve for this cubic then. It's a cubic, so it's most likely going to go down, up and down, or up, down and up. Okay, so find the turning point. So we need to get dy dx and let it equal 0, don't we? Let's do that. 3 comes down, 6x to the 1 less. 2 9s are 18, x to the 1 less, which is x to the power 1. X goes to 1, 12 lots of 1 is 12, and the constant goes to 0. There's dy dx. Turning point is when it equals 0. Now there's a 6 common. Let's take that outside, and then we'll hopefully be able to factorize. Because these questions are designed to make it, most times, to be able to factorize 2 1s. Has to be a minus and a minus to get minus 3, doesn't it? So that tells us that x minus 1 equals 0, or x minus 2 equals 0, for this product to equal 0. This happens when x is 1. This happens when x equals 2, doesn't it? When we move the numbers across. Okay, there's the turning points then. So we can get the y values or we can get the second derivative. Why don't we just get the second derivative, see which is a max and min. So here, 12x minus 18 1s, because x goes to 1. So at x equals 1 then, and x equals 2, what do we get? Put 1 in. 12 1s are 12, minus 18 is minus 6. So that's negative, so max. And this one, put 2 in. 24 minus 18 is 6, positive. So min. So we know that this is a max, we know this is a min. We don't know how high or low they are because we haven't got the y values. So let's get the y values. So at x equals 1, x equals 2, y equals. So what have we got? 2x cubed minus 9x squared, 2x cubed minus 9x squared plus 12x plus 5 plus 12x plus 5, 2x cubed minus 9x squared plus 12x plus 5. The input value here is 1. So we've got 2 minus 9 plus 12. 14 take 9 is 5, plus 5 is 10. And when we put 2 in, got to be careful here, this is 16. 36 plus 24 plus 5. Minus 20 and 29. 29 take 20 is 9. Okay. So I'm not getting the numbers I want, so maybe I've written it down wrong. Let's have a double check on question 5. No, we're on 4, aren't we? Okay, if we've written down this correctly, 2x cubed minus 9x squared plus 12x plus minus 5, that's fine. So have I written that down correctly? 2x cubed minus 9x squared plus 12x plus 5. Oh, I've got a minus 5 here. That helps to, that will change it, so it's minus 5. So instead of adding 5, you take away 5, that's going to be 0. And here, the same goes here. So it's going to be minus 1, isn't it, when we work it out? And this is going to be minus 1. Because instead of adding 5, you're taking 5 away. Okay, that's better. So we've got these points now. At x is 1, y is 0. This is the point 1, 0. And when x equals 1, it was a max. So it goes around like so. Oops. I might move that above because it's a max now. And then when x is 2, it must be a min, mustn't it? Yeah, min. And we had minus 1. So at 2 then, the value is minus 1. And that's a min. So remember we said down, up and down, or up, down and up? Because a is positive, it's going to be an up, down and up curve. Had this first dominant term been negative, it would have been a down, up and down. That's just bookwork on this. So this is what we've got then. We've got an up, down and up. So I'm going to try and draw it now with this digital pen as best I can. So it's going to come round, turn, go up, turn, and then go down like so. This point here you could work out for the purposes of the sketch because it's easy to get. When x is 0, 0, 0, 0, minus 5. So you could put that in as well as a bonus. That coordinate there. Okay, and that's the curve. Y equals f of x.